I'm going to be helping out for today. And then going back to next week, we'll be back to our regularly scheduled program with Rajarshi. But in the meanwhile, let's have some fun, you and I, and we will get blasting through this. Alrighty then. I do want to go and kick things off. Today's going to be an exciting session because today is one of those days I feel that we're going to be covering one of those topics that like really gets you into what programming is all about, in my opinion. It's honestly like one of the coolest things. We're going to be quickly talking about scope and that global keyword because I know that's the most confusing thing ever. So it won't hurt to go cover that again. We'll be talking about Booleans and then we'll get to the really fun stuff, if and else statements, and we'll go and see how that is all tied in for today's session. So I do want to say that one of these really, really cool things that I'm pretty sure you all know about here is autonomous vehicles, self-driving cars. You basically can go and say, put a Tesla on the road and say, go and point yourself and figure out how to drive better than a human can. And what's really kind of interesting, in my opinion, is that self-driving cars, AI, machine learning, all these super complicated things, they're actually just really, really sophisticated, complicated versions of if statements. So you guys, I feel, are actually learning the same fundamental basics that everybody in autonomous vehicles has to go and understand themselves. So you got to have your inputs, like your sensors, your actuators. You got to have the algorithm itself providing inputs here. And then you got to go have some very, very powerful processors here. But all at the end of the day, it really is just doing some simple thing here. It's just saying, if there's something in the way here, turn to go around it. If there's, I need to stop, hit the stop sign here. If there is the road, I need to go and accelerate on there. And really at the end of the day, it's amazing technology to get self-driving cars here. But I find it fascinating to think that you can really boil it down and realize it's simply stuff that it's basically programming, very, very complicated programming. But it is effectively just one really cool way how the same sort of programming you guys do can build up to working at Tesla. And I think that's amazing. Anyway, let's jump into the main program for today's stuff here. I'm going to go and quickly start about talking about scope. Hands up if any of you guys got completely confused trying to talk about scope last week. Yep. Yep. Okay, we're definitely seeing some people here are like, yeah, I'm confused. Yeah, and absolutely same here. When I first learned about scope, it was totally wacky trying to figure it out here. So we'll go and give a quick recap over this. Basically, what we want to say is that variables kind of have a spot where they belong. They live inside a small little area. And those areas that they belong in is basically that tabbed indent section. So inside that def setup area or that def draw section. And that variables don't really naturally exist. They're local, as we call them. But sometimes we want them to exist. Let's go and take a look at it. Yeah, here we go. I'm going to go and just show you right here. I got a little piece of code ready to roll. And let me go and make sure I got the right tab open. You guys are all able to see this, okay? I'm going to start with my typical stuff right here, my import Spark, %reload extension Spark. And then I'm going to go and show off this here. So we got our code and we say we got setup and we got this variable X. And just as I was saying before, it lives inside here. And what I mean is that anything that lives also dies. We create this X variable. We say, I want to go create this variable called X. I'm going to assign it the value of 20. And I'm going to get started with this here. But at the end of this, when the indent goes back to normal, what does this do? I basically just throw it away, pretend it never existed at all, and it disappears forever. Down here inside draw, when I say I'm going to set the value of X equal to the value of X plus 1, we're going to have a problem because I'm going to say set the value of X to something that doesn't exist. And you can see this error message show up on your screen here. Error in draw. Local variable X referenced or trying to use it before it is assigned, or in other words, created. I'm going to try running this code. Same message. It's going to be really angry at me. I can try drawing a circle here. Like, here, I'll just get rid of this line of code. Remember, you can just use Control/ to quickly comment in or comment out a line code. It's basically saying X is not defined, or oops, or you can say it's X is local variable X is being referred before assignment. Basically, the computer saying, hey, what's this X thingy we're talking about? And I'm like, well, I want you to talk about, yeah, Tane, hope I'm not saying your name wrong. You absolutely are getting it right though. Essentially, this setup section knows what an X is. The draw section does not, because X lives and dies inside of here. X dies. So how do we go and promote it? We want to say, don't stay local, be global, give the entire world a hug. What we can go and do with this is that we can define the variable out here. So I'm going to go and say X is equal to, I don't know, I'm going to start with 0. And so this is the first line that we ran. Down here inside setup, then we're going to be changing the value. X is 20, okay, sure. And then down here, draw is the next thing that runs. And I want to say, hey, I want you to go and grab access to it. Still angry at me because it's like, I have no local X. There is no X living inside here. That's okay. I don't want to use the local X. I want to use the global X. And by punching in this keyword here, global X, I get access to it. Running that code, I now have my circle here. And this was fundamental. Now, when I see X, that says, don't look for the local one inside here. Look bigger. Go to the big stage and grab this X, the one that we defined on the outside world here. If I wanted to also do a Y variable, let's just say Y equals 100, and I'm going to go global Y. We can also go down here. Ooh, that's a great catch, Billy. I'm going to answer that in 1 second. The answer is that it's complicated. I don't want to get into too specific of a details here. It's basically if you are reading the X value, if you're just simply saying, I want to look at it, but I don't want to change it, it usually works out. But if you want to try assigning it, you definitely should stick with the global variables. So actually, that's a great call. We should use global X and Y here. And then I'll set Y equals to 200. And there we go. For the sake of today's conversation here, we're always going to assume that you need this global keyword whenever we talk about global variables. There's a couple rare situations where you can skip that. We're not going to be covering those situations here. All right. Any questions about this global local variable scope thing before we jump into our regularly scheduled program? Thanks, Issy. The idea is that we do want X to 20 or X set to 20, X is assigned to 20 to override it on purpose. Yes, that is actually correct. This X here will say, use the global X and change the value up there. For now, you guys don't need to worry too much about these specific ones. We're going to be mostly focusing down here inside the draw function. My code's going to be basically the exact same as we saw it before. We can ignore the setup function, just runs once. You only usually need to put this size function in here. All right, jumping back into our code today. Let's go and see. Okay, we got our nice little X's defined at the top. We global X to access it, and now we can run our code with it. Let's just keep going with that. Okay, so now we're going to go and talk about something called Booleans and comparisons. And I feel that these are really big, complicated words, but they're actually very natural concepts. And once you see an example, it totally makes sense here. So last time we were talking about variables, and we were talking about things like strings, those ones in quotes, or integer, those 1, 2, 3, 4, 5s, or the floats, which is like 0.2 or 3.14. I'm going to introduce another one for you. We're going to go and introduce something called Booleans. And these are actually very, very simple. They're one of two things, true or false. That's it. It's just good old-fashioned binary style thinking right here, yes or no. And Booleans actually come incredibly useful, even though they are incredibly simple. And I know they're a little bit tricky to capture why they're so useful, but we will definitely see examples coming on in the future here. But let's go and get a little bit of an example on, hey, what is a Boolean? How do we use it? So for most of you guys here, you guys are somewhere between grade 9s and grade 12. So you guys are in high school. Is that true or false? Well, that is going to be true. And I do want to emphasize here, I type it out all over again, TRUE, capital T. Is it summertime? I'm looking outside, seeing that billowing wind and those bitter cold winters or falls that we're having. And I know it is not summertime. That is false. Again, capital F, got to make sure. Yes, it is definitely not summertime. I can agree with Billy's statement. So Booleans are quite natural, I shall say, for you to you basically say. So how about another one here? Let's try it out. Um, let's go with this. Is or hang on, this is not a great example here. Let me go and try another example. Is programming awesome? Is this true or false? I might be a little biased with this answer. It is obviously true. Thank you for that, Kristen. Programming is definitely awesome for sure. So I think that pretty simple stuff here. You just say yes or no questions here, simple logic here. And now we can start talking about another very, very natural thing to talk about. You guys remember from back in elementary school, when you start asking these questions like, hey, which number is bigger? Is 3 bigger than 5? Yes or no? Is 5 bigger than 3? Yes or no? And we can go and just make this into, I'll make it into a little bit easier to read. Let's go and say the temperature outside is -3 degrees Celsius. And we can go and ask a very simple question. Is it frozen out there? Is it below freezing temperature? Is freezing is set to the value of the temperature lesser than or equal to 0. And so with this -3 here, we can easily print this out. Print, is it freezing? And I'll print is freezing. And let's see if we can get some predictions in chat. Will this be true or false? All right, we got true, 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 true. All right, that's simple enough. Let's check it out. Oh, never mind. I got an error message. That is embarrassing. I think that's because I got a typo. Yep, typos be my bane. Is it freezing? Yes, that is true here. Let's go and switch it out. Simple case here. Let's go and say it's a balmy 20 degrees now. Is it freezing anymore? Freezing, is it freezing? It is now a false statement here. All right, that is so simple. You guys got this easy. You got lesser than, lesser equal, greater than, greater equal. And I'm going to go and highlight the equals to and the not equals to. Because we've been playing so long with single equal sign here, and we've been telling you that's not the same as math class. We want to go and check out when are things actually the same. Let's go and try out, let's modify this. I got one example down here is it the same? Here we go, let's try that again. Is the same is set to the value of x is equal to y. So if I print oops, is same, do we expect this to be true or false? This one here, perfect, super easy. This is definitely true. And that is, oops, just add the label here, print is same. Actually, you know what? Sure, show you guys a shortcut. You can actually just go put is same, and then you can put a comma to go and separate your things, and you can print it out all on the same line. Is same? Yep, definitely true here. And because we don't have a fancy keyboard for slash exclamation or slash equals, we're going to go and use the exclamation mark instead to say, is it different? So 100 is set to the value of 100. So next one, print is different. I can't spell today. Is different. What do we think this one's going to be? This is going to be false here. All right. Easy enough. It's 100 is not different than 100. They're the same thing. So clearly that's going to be false. And I saw a great question here. You're wondering, why is there a double equal sign here? What does this thing say? That is very, very important. It is not the same thing as this single equal sign here. The double equal sign is saying it's a yes or no question. Is the left side equal to the right side? Is the left side the same as the right side? That's what the double equal sign means. Yes, exactly. Billy has the wording down perfectly right. The double equal sign is the equality operator, the comparison operator. Single equal sign is the assignment operator. And if you guys get those mixed up, your programs are going to have a very, very bad day. So make sure you guys pay attention to that little difference there. Let's carry on, shall we? I think that, oh, I already showed off a whole bunch of examples here. We got 1's lesser than 4, obviously true. Is -5 greater than 0? Obviously false. Is 0 the same thing as 57? Well, they're not. But is 0 different than 57? Yes, that is true. So, honestly, this is probably one of the easier things. You guys just get naturally straightforward. Just that double equal sign is the one thing I tell you guys to pay attention to. But I do want to go and highlight another one here that is pretty important to talk about. And admittedly, that example is a little bit contrived. So what I'm going to go instead is just jump down to this other example here. So you guys already got my primer for this. Is programming fun? Yes, absolutely. Yes, I need to see some nodding heads here. Yep. Is programming useful? Yep. Yes. So now if I ask a bigger question, is programming both fun and useful? I should hear people saying yes, absolutely. Perfect. You guys are great at this because obviously programming is fun and useful. I can go and represent this in code too. Let's see. Okay, I do have it written up all the way down here. I say, is coding is fun? Yes, that's true. Coding is useful? True. Coding is fun and useful? Obviously. And I'm going to go and just hide these ones here. I want to focus just on this first step. And there you go. Coding is fun and useful. I think it's pretty intuitive what this means. But we got to go and talk about a different scenario here. Let's go and take a little bit more of a nonsense scenario. It's almost Halloween. Why not? Does Halloween have candy? Yes, it does. Does Halloween have Easter eggs? No, it doesn't. Either that or you live in a very strange part of the world. I want to see it if that's true. But now I want to go and ask a new question. Does Halloween have candy and does Halloween have Easter eggs? Are these both going to be true? What are people's thoughts on this? Nope. Nope, it is going to be false. Let's go and print that out. Halloween has candy and has Easter eggs? That's going to be false. But let's go and flip it out. What if we try changing out this word and for the word or instead? And so I'm going to ask a new question. Does Halloween have candy or does Halloween have Easter eggs? Now what is our answer going to be? Yes, you guys, easy enough. Man, you guys make my life so much easier when you guys can just do all the hard work for me. But yes, absolutely. I want to go and introduce the idea that you can use and to shove two different ideas together. And you have to ask, are both of these true at the same time? And we can use or to say, is just one of these true at the same time? Either or, doesn't matter on that one there. There is one last keyword that I do want to go and say is that it's not. And we use this occasionally. And I'm going to say, okay, if you guys remember Green Eggs and Ham, Dr. Seuss here, like green eggs, we remember the main character, he hates his green eggs here. So we're going to say print not like green eggs. And let me just go with that print statement again. That's a great question here. Why would you like green eggs? Do you not like green eggs? So let's see if you guys can figure out this one here. The not is going to flip it around. So what do we expect this one to print out? Perfect. Easy enough. You guys just got to go and work through the layers here. All right. The opposite of false, not that, going to be true. There you go. So you guys are already masters at Boolean logic. Congratulations. Very complicated word for a very simple 0 or 1, true or false kind of thinking here. Why is false and false false? Oh, that's an interesting question here. So Billy's asking us a question here. Let's go and take let's see. I don't want to ruin my beautiful coding example here. I'm going to go and let's go and create a brand new example down here. What about false and false? What the heck does that equal to? So we're going to go and say, is summer? Is clearly that's false right now. And we're going to also go and say, live on Mars. Yeah, that's also false here. So now the question is, is it summertime? And do we live on Mars? Phrase is summer and live on Mars. And what can we predict on this one here? We're going to go and see another round of false. Oops, and I forgot to go and add a statement here. Summer and Mars. And the question is, why is this the case here? The reason for this is quite simple, because the and statement says, are either of these true? We're not really concerned about the false cases. In fact, as soon as you read a false statement, we say, we don't even need to care about the rest. I obviously know it's not summertime right now, so why do I even need to bother asking if we're on Mars right now? Oh, that's not good. I hope that doesn't affect it. That's a bad omen. 503 different ways that this can go wrong. Let's hope that that does not completely ruin my day. I am going to just go and hopefully none of you guys are running into that problem. And in the meanwhile, while that is happening, I got a backup that is exclusive to my computer. I'm going to set that up in the meanwhile, just to be on the safe side. Why would you not just print false? Cohen, that's a brilliant question. And the answer is that I will show you in a moment. The reason for this is kind of the same train of thought on why do we use variables? Why not just punch in, if x is equal to 100, why print x instead of printing out 100? If we already know it is not summertime, why are we printing is summer instead of printing false? And the answer is it looks contrived today, but the brilliance of it is when we get things that are changing. And I think that the better way of showing this is what happens when we start asking questions around this, and what happens when we start changing these things where the answers are not so obvious. So that is perfect segue into asking these things called if statements here. So an if statement, I think, is actually pretty darn intuitive. I already illustrated an example of our driving cars. With our self-driving cars, if there's a person right in front of me, then I want to turn left and I want to avoid that person there. If the person is on my left side, I want to go and turn to the right. If statements basically let you go and do something that's pretty darn obvious and, in my opinion, brilliant, because it unlocks the power of computers. If something is happening here, then you could choose to respond to it. And this is really where it unlocks the brilliance of where anything is possible on computers. And this is where logic is really born. I'm going to go and try talking about, let's see, just make sure I'm on the same lines here. Let's go talk about a thermostat kind of example. So let's go and say, obviously I've exhausted the fact that it's not summertime. Inside my house though, it's a little bit cold. Let's go and say the temperature is just 15 degrees. And that's a little bit too cold for me. I'm going to say if wrong language, sorry. Programming in wrong language these days. I'm going to say if, and I'm going to go and ask a question. I'm going to go and put one of these Boolean statements into here. I'm going to say if temperature is lesser than, let's say 20 degrees, I'm going to put down a colon right here, just part of the same syntax here. Got to memorize that. When I press enter, you guys notice I have an indent here, and that's okay. I'm just going to overwrite it, ignore that error message. If the temperature is lesser than 20, I'm going to print turn on the furnace. And print go back to TD code. And what we should be able to see right here is, let's run that code. Oh, sorry. It forgot that this cell ran. We can just import Spark, %reload extends Spark, and we can go back to where we last were. We have the temperature, it's only 15 degrees right now. If the temperature is lesser than 20, we're going to go and start running some special instructions now. As soon as there it goes, as soon as it runs. We're going to go and turn on the furnace here. Then I'm going to get out of my indents here. I'm going to go back to my normal talking here, and I'm going to go back to my teaching code here. So we can go and start making things happen. And let's go and say maybe it's a lot warmer now. It's warming up, and now my house temperature is 22 degrees. What's going to happen now? Well, when I run this code, if the temperature at 22 degrees is less than 20 degrees, well, obviously it's not, this is now false, we would turn on the furnace. Naturally, there's nothing to turn on now. Now, we're going to just go back to printing our code. And now to go and answer, oh, no, this is wrong stuff. You can ignore all that. Here we are, back to my slides. Let's go and talk about a visual example here. With a simple if statement, you can get some really, really nifty effects here. You can say, if the ball is on the left side of the screen, make it happen. Otherwise, make it disappear. Shall we go and put that into code? Let's see what that looks like. I'll type it all from scratch just so that you guys can join in with me. So we're going to go %, ignite, and we're going to go start with our usual def setup, open round brackets, close round brackets, colon, press enter. I'm going to just type in the regular stuff, size 500, 500. And then I'm going to go and type in some of the more regular stuff down here. Def draw, open bracket, close bracket, colon. I'm going to go for a background. Let's go and make this background. Somebody want to give me their favorite color in chat? Red, perfect. Thank you very much for that. And we'll go and set the fill style to draw this ball. I'm going to go and make that blue. And now, regularly, we can go and talk about drawing a circle. Mouse X, mouse Y, and maybe 50. And then we got this blue circle on this red background. But with a little tweak, we can change this code. We can say if mouse X is lesser than 250, colon, press enter. What I'm going to do, I'm going to take this line of code here, and I'm going to just go and press tab, make it indented one layer to respond to this if statement here. When we run this code, if the ball is on the left side, if it's less than 250, we're going to draw it. But when we cross that 250 barrier, boom, it disappears. So to answer Cohen's question, again, one more time, why do I not just simply draw the circle every time if I know where the ball is? The answer is, I don't always know where the ball is. It's going to change. This mouse X is what we call an output. The circle is drawing here is going to be the output. We got inputs, something happening down the middle, output. And now we can have code that reacts and make things happen. I'll go and copy this example into here just so that you guys can catch along and follow along if you need. And we're going to carry on to here. Naturally now, I want to go back to that thermostat example here because, well, my house is nice and warm. My house is just fine and dandy here, and my temperature was 22 degrees. Let's go and say I'm a very fickle person who says I always want to keep the temperature right where I want to keep it. If the temperature is 20 degrees, I'm going to, or lesser than 20 degrees, turn on the furnace. Else, I'm going to tell it, hey, when the temperature is not lesser than 20 degrees, I want you to print turn off the furnace. And so let's go and take a look at what happens. We have 22 degrees here. It's going to be a little bit too warm for me, and I don't want that furnace on. So I'm going to say, is it less than 20? No, this statement is false. We're going to fall down into this else statement. Okay, what happens then? If we're not going to go do this first half, we're going to do the second half. That is, turn off the furnace. The else statement is just the natural extension on the if statement. And I feel that once you guys get a chance to mess with it, it's pretty obvious. I do want to highlight one more time that the syntax here matters and just little minor things. You got if statements, you got your else statements. There is no conditional operator here. You just simply put colon straight away. And same indent down here. And boom, bada bing, bada bam, bada boom, you can make things happen. And now you can have your code react in totally different ways. And I'm seeing these people here telling me that Scratch is fantastic. And You got to see these diagrams, I'm thinking, you got your scratch equivalents, and wow, it's pretty cool. What about making the ball do something a little more interesting? If the ball's on the left, or if the mouse is on the left side, draw it. If the mouse is on the right side, let's play a little bit of math on it. So what I'm going to do is change this disappearing ball to a mirrored ball. And I'm going to say, if the mouse is not on the left side, in other words, if the mouse is on the right side now, else, colon, mirror effect. And I'm going to say mirror x, I'm just going to make a variable here, is equal to 500 minus mouse x. This is not a math class, so don't worry too much if you don't like this part. Just follow along, have some fun with me. We're going to go for circle, and I'm going to say on this mirror x. I'm going to stick with the same mouse y, I'm going to stick with 50. And when we run this code now, on the left side, if the mouse is less than 250, we're going to draw the regular circle. But if it's no longer on the left side, we're going to go into the else statement. We're going to go and recalculate a brand new x statement, and we're going to get some really funky effects that can come out of it. And we can get this mirror effect. How many of you guys think this is awesome? I just love when you get to go and make really cool things like this with a simple line of code. Yeah, honestly, I'm having such a good time showing off these kind of things. Okay, now I'm going to go and challenge you guys here. Let's go and take that same mirrored example here, and let's pay attention to the code here. I'm going to give you guys 1 minute to think about this, and I do want you guys to pay very careful attention. Let me know, what color is this ball going to be? What color is this background going to be? Pay attention to the order. Ooh. Oh, this is interesting. All right, last 5 seconds, get those votes in, get those votes in. All right, and we're going to call it there. Thank you very much, guys. We're going to go and call the time right there. So, what's really interesting about this, oh, let's see. The most popular answer actually is not going to be the right answer. It's a little bit surprising, and I really hope that we did mark this right. Otherwise, that'd be very embarrassing for me. But let's go and type this code together, and let's figure out why. Ignite, def setup, and I'm just going to blast through the usual stuff. Size 500, 500. I'm going to go def draw, colon. I'm going to make sure I'm getting this right. Oops. Let's see. We're going to say if mouse X is greater than 250, make it red. Else, background blue, fill style green. And then, what's this? Another fill style yellow. Let's see what that is. We're going to go if mouse X is greater than 250, background red. Else, background blue, fill style. I got a little typo there. That should be an underscore. Green, and go back 1 indent. We're going to also say fill style yellow. I'll space that out, make it a little easier to read. Circle, and we're going to go and draw our mouse X, mouse Y, and make that 50, and boom. Let's draw that. And what we got over here, the background is blue, the ball is yellow. And now the question is, why yellow? The background blue should be clear. We got a mouse X that is lesser than 250. We skip this statement. So we're going to grab the background blue. Why not green? Well, the thing is, we do set it to green, but down here, we're going to be changing it to yellow. This code always runs no matter what happens. Red side, gonna paint it yellow. Blue side, gonna paint it yellow. This line of code always is gonna run every single time. It's a little bit of a tricky one there. But now I'm gonna go and pass it back to you guys. We're gonna go and take, let's say 8 minutes, a little bit behind schedule on this, to go and create this example right here. The question is, you're gonna need to use an if statement to check which part and when it is true. If the ball has done something, then you want to set its position to somewhere. Let's try it out. Let's go and take 8 minutes to do this. All right, welcome back, welcome back. How'd you guys do on that exercise? How many of you guys were able to complete it? Nice, nice. We got some people who got it. Perfect. Was there anybody here who got completely stumped? Yes. What the heck was that exercise? Seeing a lot of people here. Okay, got a handful of people who were trying to figure out what the heck's going on. Handful of people who were able to finish it successfully. I think we got a good mix on that. I'm pretty happy. Let's go and quickly talk about how to get this working. So I'm going to go do our usual. We're going to go and set it up. This time, I do need a global x variable. I'm going to say x is equal to 0, and I'm going to go with global x. That's necessary here. And we're going to go background black. I'm going to go background shorthand. I can just use 0, and I'm going to use fill style of white shorthand. That's 255. And I can go and get myself, let's just get the basics done, circle, and we're going to go and put a ball at the x coordinate. I'm going to maybe put it at 25, or yeah, we'll go and put it at 25, and I'll go and make this like 50 tall. Boom, got that lovely little white circle there. We're just going to go x plus equals, let's go 3, and we got this ball marching along right here. And now we need to go and add an if statement because, whoops, bye-bye ball, we'll never see you again. What we can do with this to make it teleport, we ask the question, when do we want it to come back? The answer is, when should we check? We check right on the edge here when it reaches the edge. If x is greater than the width of our screen, that's going to be 500, then what we're going to do, we're going to now say, hey, how do we bring it back over to where it began? And that is where we just simply say x, oops, what is my computer doing? X is set to the value of 0. Let's check that out. The ball goes, and then reaches here, boom, it restarts right at the beginning here. And this works for pretty much any speed I want. 10, blazing fast ball here, and which is honestly kind of useful. I did 11, and just showing off here. We can do that, and it works fine. And for those of you curious, why not just use if x is equal to 500? Because 500 divided by 11 is not a clean number. That's so if you can, pay attention to which operation you use. Greater than sometimes has its advantages over just plain old equal sign. All right, back at it. Let's talk about one last keyword here, elif. No, that's not an elf that grew an extra I. It is else if we put together here. So this is kind of the third cousin. It's the one that you don't need to use too often, but it is sometimes occasionally useful. Let's go say I want to go and purchase this really pretty green circle. Don't ask me why. But I know it's like, okay, I don't want to spend too much money, but I'm hoping I can find it on sale. If I find this thing and it's cost more than $40, I'm going to be like, that's way too expensive. No, thank you. If it's under $30, I'm going to be like, wow, that's a fantastic sale. And I do want to grab it. But what happens if it lands somewhere down the middle and I want to have this code react to that somewhere down the middle, that not quite scenario? This is where elif is useful, or this else if statement. So let's say we can go and check out if this price is greater than 40, well, we're going to go and follow this too expensive thing. Not going to happen. We're going to say, nah. Elif, it's just another if statement that ran after the first if statement. The price is greater than 30. Oh yeah, this is good right here. I mean, like, yeah, it's a good deal. It's not fantastic, but it's a good deal. I think I'll take it. And then we got this else statement here. It's like, what if that wasn't true? Well, then we can go over here. Quick pop quiz for you guys. What if the price was $45? What will be printed on the screen? Too expensive?
Yes.
Perfect. Too expensive. Absolutely. What if the price is $27? What will we see then? Great deal. And somewhere down to happy medium here. Let's try, ooh, I'm going to try to trick you. What if it is exactly $40? I can't trick you guys. You guys are too good for me. Oh, I got a couple people. So it is going to be just a good deal. Why? If it is exactly 40, that's not greater than 40. That's exactly equal to 40. So that's where we're going to go say, oh, it's actually exactly equal to 40. That's going to be considered a good deal here. What if it was $0? Great question. Let's check it out. 0? Is 0 greater than 40? Nah. Is 0 greater than 30? Nah. It's free? Nah, that can't be right. Somebody's got to be pulling a prank on me. Something's all right. Either that or that's a bargain of the century. Yeah, exactly. I didn't use a greater than or equal sign. So good eye. Pay attention to some little details like that. Always be careful with things like that. So I'm going to go and give you guys a quick recap on one of those previous examples. Remember when I said you like green eggs and ham? You like green eggs? Nah. You like ham? Nah. I'm just going to recap. If you don't like green eggs and you don't like ham, yeah, you could shove them together into a nice big if statement right here. You don't like them, Sam, I am. What I want to go and highlight is that you can, yeah, use the and statement right inside your if statements, just like we saw before as well. And we can go and bring it together to go and kind of illustrate this kind of cool example right here, where we can get multiple quadrants. And instead of green eggs and ham, we're going to be checking mouse X and mouse Y. Let's go see that in action real quick. I'm going to go % ignite, setup. I'm going to go my usual size 500, 500. Wow, I really need to just copy paste this to make my life a little faster. Def draw, colon, I'm going to go background, and let's just go to 55 for white. And we are going to say if mouse X is greater than 250 and mouse Y is greater than 250, fill style, I'm going to choose a green color. So that's going to be RG, full G, B. I'm going to say green. Else, I'm going to say if it's not in that specific area, fill style is going to be blue. 0, 0, 255, blue. And then we're going to go on our circle. And I think I already kind of spoiled the fun by showing you the picture of which area is it going to show up like that. Oh, can't use X. I got to use mouse X, mouse Y, and I'm going to drop 50. It's going to be blue anytime it's in the top left or the top right or the bottom left. But if it's both in the right side and the bottom side, then we're going to go and change it to green. So there's this nice little quadrant down here where we got green. Got a question here. Why not do if not instead of else? Interesting question. The answer is I'm lazy, and I think else is just much faster for me to type. Theodore, make sure you run the very, very first cell up here, that import Spark, reload X Spark, and then you should fix the rest of your problems. Can you use or inside an if statement? Juliana? Yes, absolutely you can. Let's try it out. If mouse X is greater than 250 or mouse Y is greater than 250, then we're going to see this. Actually, I want you guys to answer this for me. Top left. We're going to go top left, top right, bottom left, bottom right. And I got have you guys answer that question for me. What color is the top left? What color is the top right? What color is bottom left? What color is bottom right? Let's start. We'll start with, let's say, the bottom right. If the mouse X, or if mouse X is over here, that's going to be greater than 250. But let's say it's on the top side. If it's less than 250, what color is that going to be? It's going to be green. In the top left, right, it's going to be green. How about we flip around? If it's greater than 250, but less than or greater than 250 on the bottom, the mouse X is less than 250, it's going to be green again down here. Down in the bottom right, I'm going to say it's, yeah, both of them are true. That's green. And the top left, if it's less than 250 here, and it's also less than 250 here, so neither of them are true, this is going to be blue. So with the or statement, you got a lot of green and only just one tiny area that's going to be blue. You can have really fun making some combinations out of these kind of things here. This is what you call a truth table. If you go to university, you're going to write a whole bunch of these for your programming classes. But now I'm going to go and bring it into a quick question for you guys here. I'm going to go and throw in an elif statement. Let's take 1 minute to answer that. Yep, sure thing, Tane. I'll send that. And yep, here's a quick question again. Oops. We got the wrong poll open. Let's go for poll 3, S3Q2. Perfect. Thank you. Thank you. All right, 10 more seconds. All right, and let's wrap things up right there. Interesting. We got the right answer, eking out right at the last moment. I was watching those polls. It was really interesting. So the answer is going to be green. How do we know that? Well, we go and take the mouse X and mouse Y, and we're going to work our way logically from top to bottom. If, elif, else, in that order. So mouse X is 150. Is mouse X greater than 100? Yep, check that off. And is mouse Y greater than 100? Ooh, no, it's not. 50 is not greater than 100. One of these are not true. So we're going to skip this statement. It's not going to be read. Elif, so else if, mouse X is less than 100. Well, no, that's not true. Or, ooh, interesting, mouse Y is less than 100. Oh, yeah, 50 is less than 100. This is true. Or means one of them is true. Yes, the whole thing is true. We're going to use red, green, green. We're going to choose green here. And with the elif, that means we're done. We skip out of it. We do not follow the else statement at the end here. And then we can go and print out our nice little green one here. So I see a bunch of people answered blue. My guess is you guys probably jumped into the else statement afterwards. Just remember, if the elif is true, jump on out. You're done. That's what this diagram shows. If statement, if that side's true, jump out. Elif, if that's true, jump out. If both of them are false, then you do the else statement. All right, I'm going to go give another 8 minutes for this. Again, what I'm going to do, just prime you guys. I'm going to go and paste this code. I'm going to swap over that or statement to an and statement. And I think that you guys can use this as just a little starting point to go and draw this. Let's take 8 minutes to work on this exercise too. I'll see you guys afterwards. All righty then. How many of you guys managed to get it all done? Nice, nice. Cool. Sweet. I'm liking it. It sounds like a lot of you guys managed to cover it off. For those of you guys who weren't able to finish off, no worries. I think that there's one thing I didn't actually tell you guys. The color, whatever, just that, whatever, man, whatever color feels good. But let's go quickly run through the answer real quick. And make sure I got the slides open to show off. So let me see, red in top left, green, yellow, blue. All right, it's going to be a while before I can memorize those colors off the top of my head. I'm going to say if it's in the bottom right. So if in bottom right, I'm going to go and choose blue. And I'm just going to use a lazy or the easy version. I'm just going to say then blue so I don't have to memorize it. Blue. And then we're going to go and say L if some condition here. Some condition, I'm going to go replace that with L if mouse X is, let's keep it systematic, is greater than 250 and mouse Y is lesser than 250. So that is going to be in the top right quadrant, and I already forgot my colors, and that's going to be green. All right, so we're going to go and set it to green. Now we're going to say another L if. These just chain on inwards. So if the first L if is true, we're done. But if the first L if is false, we can fall into a second L if and do the same thing all over again. Let's try it out. So let's go and do a flip over from this one here. If mouse X is less than 250 and mouse Y is greater than 250. Let me just go and label these quadrants just so that we remember here. This is right. And then this one here is going to be bottom left. And that whatever color, it's like, yellow, whatever. Now this final one here, last quadrant, is going to be top left. We're going to go and set that color to, which one have I not done yet? Red, that's the one. Red. Let's delete that confusing comments. Run that code. And there we go. We managed to get it changing colors in every single quadrant. And thankfully, I remembered my colors right. But the LFs depend on the order. Yes, absolutely does depend on the order. That is a very smart observation here. If you want to make sure that LFs are good, make sure you're double checking. Check each order here and make sure top to bottom on that. I could show you there is one little hack where you can theoretically, instead of just elif, you can run this as an if statement. This code runs. No matter what happens here, this code runs afterwards. I'm not going to talk about that today, though. It is a little bit more of a deep dive on when you would want to handle those kind of cases. So for now, we're going to keep them together, chained up in one big elif chain. Excellent question, though. I love it. All right, final thing here. This is actually just a really quick and easy one. We're going to be checking out, we got mouse X, mouse Y, these magical things that make it a lot of fun to draw things. We got mouse is pressed too. And this is a Boolean. It's going to give you a simple true false question here. True is, yeah, you're holding down the mouse, and false is when you're not holding down the mouse. Let's go and see it in action here. I'm going to go and draw this. Let's go and do it together, shall we? So I'm going to do my usual %% ignite, def setup, colon, and then we're going to do size 500, 500. And this, as the same thing as before, works a lot better inside the draw function than the setup function. Let's go background, and we're going to go with pink because I need a new color to look at. And we're going to go and say if mouse is pressed, colon, fill style, let's go make it red, and then else, oops, I missed a colon there, shame on me, else colon, fill style, brackets, and let's make it obvious, black for when it's turned off. And then we're going to go and say circle, and we're just going to smack it right in the center here. So let's go 250, 250, make it nice and big so it's really obvious, make it 100, and we got that circle. When I click on it and hold it down, it's going to be red. Take my mouse off, it's going to be black. Perfect, we got ourselves a nice little on-off button. For those of you who are curious, mouse is pressed is a Boolean, which means if you really want, you can say mouse is pressed is equal to true. This is actually the exact same thing. And I personally like to write it this way. It's just a lot faster, but that's up to personal preference on how you handle that. Okay. I just wanted to show you that one. It's super fun to use, and you guys get to unlock a lot of toys with it. And I'm going to just quickly bump into the next few topics here. Just a reminder, thank you guys for showing up for us so far, and I hope you guys are enjoying it. If you want that sweet, sweet certificate to say that you are now a master of beginner level programming, you got to go and show up for at least 6 of our 8 sessions here. We are tracking attendance here. So many points riding on it. But if you want that certificate, all you got to do is just show up and keep on enjoying programming, just like how you guys already are. Session 0 doesn't count. And another quick note, I know that some of you guys been asking, how do I do my submissions? Should I go and put it in 2 separate submissions, put it together in one? Can you just do 1 submission, please? That just makes our life a little bit easier. Thanks, guys. Sweet. I think then, if you got some submission questions, I see a lot of people asking about that too. Poke your mentor. That's what your mentors are fantastic for doing. We try to get our session or these submissions marked usually within the week, but we're not perfect. We're university students, and oh gosh, you lost your main lecture lead to a midterm today. Can you just imagine how many other people we have to go work on? We got, I think, I don't know, several hundred of you guys to mark submissions on, so be patient with us. We're trying our best. Thanks, guys. Now, with that, I'm going to go and spend the rest of the time talking about these exercises here. This should look familiar. It's just the same thing as before with the teleporting ball. This time it's turning around. This one here is taking advantage of mouse is pressed. You don't need to worry about the text though, but the question is, can you go and draw the ball to chase your mouse down only when you're clicking? Pythonic lava, same thing as the other one, but this time it is now turning into that DVD logo. Honestly, for those of you curious, it's not that much different than the bug buster exercise there. Bug busters, I even challenge you guys to try it out just for fun. This one over here, I love the animation. It looks like a little balloon, but the idea is when you're clicking down on the mouse, the balloon should rise up. And then when you let go of the mouse, it should just fall straight back down to the ground. You're going to need a heck of a lot of if statements to get that working. And yeah, if any of you guys want to program your own physics engines or Pong games, it's a fantastic spot. This here is actually like something that we used to teach, but we take longer time for. But with that, I'm going to spend the next 15 minutes letting you guys go and chug along at these exercises here. Oh yeah, you can actually build Flappy Bird. You guys actually have the skills to build Flappy Bird right now. Did you know that? It's pretty darn cool. A little bit of work, but I think it's so cool. If anyone wants to prove to me they can get Flappy Bird done right now. Anyways, we'll talk more about that in future sessions though. For now, let's have some fun coding stuff. See you guys at 7:30.
I just have the option to join Richard's debrief right now.
Yeah, so I got to.
Oh, is that right? Okay, this
Yeah.
is really okay. My bad. I'll move everyone to the right one.